Hello everyone and welcome back. Now we're going to be going through example 9-5. Oh, as always, 9-5. There's a whole lot going on in this problem, so I'm actually going to read the problem statement this time. So it says an S4S timber column, which is a nominal size of 6 inches by 6 inches, is subjected to a compressive load of 22,000 pounds. The column is supported by a 2-foot square concrete footing that is in turn supported by the soil. It wants us to find the bearing stress on the contact surface between the column and the footing, and the bearing stress at the base of the footing. It says to neglect the weight of the footing and the column, because they're magic. Okay, so first off, let's draw it. So we have our column, which is an S4S timber, which is square. Beautiful drawing, I know. If you want art lessons, I'm happy to give them. And that column, if we actually look it up online, or in our Appendix E, it's not actually 6 inches by 6 inches. It's just like a 2x4 isn't 2x4. It's actually 5.5 by 5.5. And the footing is going to be 2 foot square. So 2 feet by 2 feet. The force it said it was applied was 22,000 pounds. Okay, so given P equals 22K, find stress of the column and the footer interface and stress at the footer soil interface. Are they going to be the same? Are they going to be different? Well, bearing stress is different than just your regular stress. Because if you look at it right here, this plane where the two materials interact has two different areas. It's got the area of the column right here, and it's got the area of this big surface. So first you might be confused about which one do I use? What's my area? Well, the area is always the smaller of the two. So in this case, that is the area of the column. So for finding the bearing stress of the column onto the footer, the equation is the same, but it's the area of the column. For the case of the footer and the ground, well, the ground is huge. It goes off to infinity, we're just imagining. And so in this case, it's going to be the area of the footer, not the area of the ground. That's supposed to be subscripts, but I'm just don't have very good handwriting. Okay, now first off, let's calculate our area. And we're going to calculate it in inches squared because we always have like PSI, pounds per square inch, or KSI, kilopounds per square inch. So let's do that first for the column. So AC is going to be equal to 5.5 inches times 5.5 inches, which is going to come out to be exactly, let's see, I think it's 30.25 inches squared. Yes, 30.25 inches squared. And we're going to go ahead and do the area of the footer. That's going to be 24 inches. Be very careful that you switch it. Times 24 inches because 2 feet. There are 12 inches in a foot. It's equal to 24 inches. And that's going to come out to something slightly larger, which is going to be, let's see, 480. Okay, I don't have my calculator with me right this second, so I'm having to actually do some long multiplication. Not fun, not fun. Didn't sign up for this. Totally did. So happy with my life. Okay, so with that, it should come out to 576 inches squared. If I've done my math right, don't hold me to it. Okay, now with that, we keep on going. So we have 576 inches squared for the footer, 30.25 inches squared for the column. And now what's the load? Is there a different load for either one? There is not. The force that's acting on the top goes all the way through to the bottom. So in that case, we have enough to solve. So the stress in the column would be, or sorry, the bearing stress due to the column would be equal to 22,000 pounds over 30.25 inches squared, which is going to be coming out to 727 psi. And I kind of ran out of room over here, so I'm going to go up here. And I get that the stress in the footer is going to be equal to that same 22,000 pounds over a much larger area, 576 inches squared, which should come out to 38.2 psi. So, as you can see, the column, there's a lot more bearing stress due to the column than there is on the ground because we spread it out. The larger the area you have, the less stress you will feel. That's why a column that is 8 miles wide, you aren't surprised if it can hold 5 pounds. However, if you take a straw and it can hold 5 pounds, you're pretty surprised because it's got a much smaller area. Stress is about normalizing it. Stress normalizes the force based on the cross section. This allows us to compare all of the different possible cross sections that we could have. So for the material, you understand what happens no matter what, as long as you're normalizing it and looking at things in terms of stress. Force is very different. Because a force on a very thick rod doesn't matter, while a force on a very small rod does matter. And there's a big difference due to the intensity of the internal force. So we have to normalize. We normalize by the area. Okay, with that, we've got our answers, and we're good to go. So I hope this helped, and I will see you in the next example. Have a good day.